Hello everyone. So let's see one more example from mathematical induction, how we can prove a statement using mathematical induction. Okay. So then we are going to see another form of mathematical induction, which is known as strong form. All right. So this is slightly different than all other propositional function, because all other propositional function we proved actually some propositional function like sum of some numbers. Okay, now here we are going to show a something like 2 to the power 2 to the power 2n minus 1 is divisible by 3 for any n greater than or equal to 1. So as we said that our propositional function and our basis step and inductive steps, they has to be very clear. So here our propositional function Pn is like that. We have to prove that 2 to the power 2n minus 1 is divisible by 3, or I should actually write it like that. 3 divides 2 to the power 2n minus 1. Okay, for all n, all right, greater than or equal to 1. All right, so here it is saying that for any integer greater than or equal to 1, this propositional function is true. So the lowest value of n we are going to use 1. All right, so our basis step is that we are going to prove that P1 is true. So what is P1? That means we have to see whether 3 divides 2 to the power 2n, which is 1, minus 1. Okay, here we just used dot as a multiplication. Okay, so okay, let me use multiplication so it will be clear, and let me write that like that. So 2 times 1 minus 1. Okay, so here we can see that 3 divides, and this is going to be evaluated as 2 square minus 1, which is a 2 square, all right, which is 4 minus 1, which is 3. Okay, so 3 divides 3. Okay, and that's true. So we proved that our P1 is true. All right, now our induction step. Okay, and first we are going to have the hypothesis that we are going to assume that pk is true. All right, so what does that mean is that if pk is true, then 3 will divide some value in the format 2 to the power 2k minus 1. Okay, so we know the division rule, right? Division algorithm. We can say that 3t equals to 2 to the power 2k minus 1, where t belongs to some integer number. All right, so this is our assumption or hypothesis. Now our induction step, we are going to prove that, and using this hypothesis we are going to prove that pk plus 1 is true. All right, and what would be our pk plus 1? Pk plus 1 is going to be look like that. 3 will divide 2 to the power actually it will be k plus 1, okay, minus 1. All right, so okay, so we have to prove that. All right, now let's actually work with this value. So what does it look like? 2 to the power 2k plus 1 minus 1. So just always remember what actually we are trying to do. We are trying to prove pk plus 1 is true using the hypothesis pk is true. All right, so actually we have to use the fact from pk. Okay, and from the propositional function with n equals to k, this portion looks like this. Okay, so somehow actually pk plus 1 is true. To prove that, we have to actually uh, somehow deduce this form into, so that we can use the fact of our hypothesis. Okay, so let's see how we can do that. So this is our value. All right, so this will look like 2 to the power 2k plus 2 minus 1, and actually it's looking good, because here I can see 2 to the power 2k, and that somehow actually looks familiar from our hypothesis. Okay, all right, so now it looks like 4 times 2 to the power 2k, okay, minus 1. And from here, from this equation, what we can say, what we can write from this, we can write replace 2 to the power 2k as a 3t plus 1. Okay, 2 to the power 2k equals to, right, so let me replace that, minus 1. So it will be 12t plus 4 minus 1, means actually it will be 12t plus 3, so which is same as 3 times, okay, so 4t plus 1. All right, so what does that tell you? That tells actually this this equation here, this statement is actually divisible by 3, and we can say that this is same as, okay, given that pk is true, all right, we are using this fact, all right, and from this equation it is obvious that this value, this statement is divisible by 3 for any t belongs to a integer number. All right, and here we already assume that t belongs to a integer number. Okay, so that proves that pk plus 1 all right, so pk plus 1 is true. Okay, and from that we can come to our conclusion step. That means for any integer n greater than or equal to 1, this equation 2 to the power twice n minus 1 is divisible by 3. Okay.